and welcome to my Lab4 presentation on rope swinging applied to springs. In this lab, I was able to track a video of an oscillating spring with a given mass and L value. From here, I was able to find Python code to create a model of the spring mass system with force and energy diagrams. I was then able to compare the tracker observations with the model for accuracy. From this, I was able to find that the model closely follows the path of the actual mass in spring. However, there is some error which can be explained by human error in marking the center of a mass in tracker and the increasing effect of the drag force. So, what fundamental principles did I use? Well, first we use Newton's second law. This will help us predict new velocities and in turn new positions of the mass within the Python code. Also, the energy principle is used and states that the change in total energy of a system must be 0. Next, I use tracker to track the position values of a mass at 0.42 kilograms, 0.402 kilograms, and a spring length which is not relaxed at 0.7 meters. I was then able to export my findings to be used later. To find the period, I found how long it took for the y position to return to its original position again. So, the change in y at the trough of the curve. I was able to find some initial conditions after this, for I can use the period with finding the Ks value and the relaxed length. To find Ks, I used the period formula and solve for Ks. I was then able to plug in Ks to the spring force equation and set it equal to the force of gravity, since the net force is 0 when the spring is at rest, and was then able to find the S value, which is the change in the spring length, and find the resting L. We then update the velocity and position values of the springs. Next, we must update where the spring is. We update L by subtracting the spring's position from the ball position. Then we calculate the direction L hat by dividing L by the magnitude of L, and then update the S position as well. Next, we calculate the energies of the system, starting with the initial conditions and then the changing values within the while loop. The spring potential energy plus the gravitational potential energy and the kinetic energy should sum up to 0. The delta K, delta UG, and delta US will help us find the change in time needed for our graphing of the change in energies. Next, I will show you my model. Here you can see that the model follows the tracker data pretty closely. The slight difference can be accounted for by an increase in the drag force and a slightly off mass plotting in tracker. Next, tracker plotted all of the energies within the system. The blue line represents the change in kinetic energy. The red line represents the change in potential energy of the spring. The green line represents the potential energy change of gravity. When you sum these, you get a value of 0. This follows, which is shown by the yellow line. This follows the law of the energy principle. Next, we show that there is a difference in the period for x and y. Like I stated before, the period for y is 0.519. The period for x, however, is slightly different. We still subtract the two congruent points for x at the trough. However, we get a bigger period of 1.62. This shows that the spring is swinging further in the x direction than the y, making the path of the mass an ellipse. In conclusion, the energy principle was met, and my model closely follows my tracker data.